Bismillahirrahmanirrahim, and welcome to another lecture of CS 101. This week we'll be looking into arrays. If you recall from the last week, we looked at functions, how to pass parameters into functions by value or by reference. We also looked at inline functions, overloaded functions, as well as recursion using functions. So next topic is how to store multiple data using the same variable name. And why do we need to do that? I give you an example. For instance, there are 66 students in this class. So if I need to store the marks of every student, it means that using what I know currently, I need to have 66 variables. So maybe student 1, S1, S2, S3 and up to S66, and then I can store the marks of all the students. The problem is, what if I want to find the sum or if I want to find the average? Ideally, if there are 66 students, I can write a loop from I1 to 66 and then sum it up. However, the problem is that every time I have a different variable. So it means that I cannot use a loop. Similarly, if I want to store a matrix, how do I store that? So with the current variables, with one variable is for a single data type and a single value, this is very hard. So for that we have what is known as arrays. Arrays are a name to a contiguous location of memory. Contiguous means a sequenced location, multiple locations that are arranged together. And using that, instead of having 66 variables for 66 students, I can have a single variable, and then I can use indexing to go through all the 66 students. So let's look at how this works. That is the outline of this chapter. This is chapter 4 from the book Detail in Detail, and we're going to look at the introduction of what arrays are, how to declare them. We're going to look at some examples, and then we are going to see how to pass arrays to functions and using other searching, using multiple scripted, maybe not the whole thing in one lecture, maybe over 2 or 3 lectures, but we're going to cover all these. So let's start with what is an array. An array or arrays in general are structures of related data items. It means that if I want to store something, they must be related. Either they are all integers, they are all strings, they are all characters, they are all booleans, they are all float, they are all double, anything but of the same data type. So that is the first thing. The second thing is that arrays are static entity. This means that once I define an array, the size of it is going to remain constant. So if I want to define the students of CS 101 section B, which is our class, and I define the number of students to be 66, then that 66 size has to remain constant. I cannot change it, I cannot increase or decrease it as I go along. So two things. First of all the elements have to be of the same data type, and secondly, the size of an array has to be constant. So it is static. The opposite of static is dynamic, which means it changes. It can increase or decrease with time. And a few types are the pointer based array and the array as objects. So in C++, which is what we'll be studying, arrays are going to be objects. Now what are objects? You'll probably learn about that in CS 102, in the next course that you have. But for now, it's just assume that they are objects, whatever objects are at this point. This is how an array looks like and how to name an array and access an array. So if I want to introduce to you what is the concept of an array, how does it differ from a single variable, I'm going to use an analogy. I'm going to use an example, and that example perhaps we are all familiar with is that if you want to go to some place, for instance some place like Islamabad, which is well organized and well structured city, and I go into a city. So for instance, this is a road, and from here I go into a street. So this is my street. So let's say this is street number 8. Just put it street number 8. Okay, so in this street, as you know, in most of our houses, in most of our neighborhoods, not everybody writes the number of the house in front of their houses. So some people will write the house number on the top or on the number plate, but not everybody will write it. So suppose I have a bunch of houses like this. Now, if somebody tells me that this is street number 8, so this is street number 8, the houses starts from house number 160 to house number 175. Now immediately I know that there are going to be 16 houses. So from 160 through 175. So if the first one is known to me, perhaps this person has written in front of his house, this is 160, and nobody else has written this information. If I want to search for maybe house number 167. All I need to do is start from here. I know this is 160. Then I'm going to count. Okay, this is 160, this is 161, 162, 163, 164, so on until I reach house number 167. Even though this person did not have the number 167 written in front of their house, but I know they are serially arranged, and the first house number has this 160. So all I needed to do was count, starting from 160, and next until I reach the 8th house. And even if it is not written on the front of the house, I know this is house number 167. So the concept of arrays are very similar. An array, if I have a simple variable, so if I define int x, x is a single variable. It means it has one location in the memory. If I define an array, so if I write an array, maybe array like this, this is a continuous location of memory, and it is divided into multiple parts. So this is 1, 2, 3, 4, 5, 6, 7. Maybe I can divide that. This is 8. So this will be an array of size 8. If I name it array ARR, now this is the address of the first location. And this tells me 8 over here is telling me the size. So this is telling me the size. This is telling me name of first location. So the analogy, if you can see from here, this was street 8, that is ARR, the name of the variable. We know we are looking in street 8, and it starts from 160 and goes to 175. So I know there are 16 houses in this row, or maybe split, or I could just, if I were to say that they are all the houses are on this side alone. So the starting point is 0, and this is 1, 2, 3, 4, 5, 6, 7. So there are total of 8 locations. It always starts with a 0, and then if there are n locations, it goes to n minus 1. This is how arrays function. If I want to go to a location just like I did with these houses, if I wanted to go to 167, I start from 160, I count 8, and that is 167. So here if there are 8 students in my class and they are seated, and I want to go to the 5th student, I'll just go to the location of the first one and then count 5, and there is my 5th student. So that is how arrays work. They always start with 0. The first position is 0, and you index it using these square brackets. So here if I want array of 0, this is this location. array of 1, this is this location, so on. Array of 5, this is this location. And how the computer does it is that I need to tell it the type, the data type of this variable array ARR. So as we said, it has to be a continuous, a consecutive group of memory locations and the same name and data type. So if this array ARR, this variable, if it is of type integer, an integer is 4 bytes. So it means that if the starting location is this is where array points to. So what is array of what is array of 4? If this is the location, starting location where array starts, it means this plus 4 into 4 bytes. I will skip 16 bytes and this location will be here. Just like I know every one of them is a single house, if I needed to go to 167, I'll skip 7 or 8 houses and then I arrive at 167. Similarly, array, the name here, the variable is the name of an array is the location of the starting point. So this is the starting point. This is array or array of 0. This is where it points to. And if I want to go to array of 4, I take the address of this location. Since there are 4 elements and each element is 4 bytes, so 4 multiplied by 4, 16. I will skip the next contiguous 16 bytes. This is the reason we say they have to be consecutive, because that is how I am indexing. अगर बीच में gaps होती हैं तो फिर ये काम ना करता. So start from here, skip the next 16 bytes, and this is array of 4. So this is how we write, and then we can initialize all the elements individually. C of 0 is 3, C out of C of 0, if I try to see out this, it will give me 3 because that is what I have assigned over here. And I can use can perform any operation using a subscript. So for instance, I can use the equality operation. I can use a variable here, C of x. So what is x? X equal to 3. C of x means C of 3, which is going to be the 4th location because it starts from 0. So 0, 1, 2 and 3 is the 4th location. Do remember that an array does not start from 1, it starts from 0. So this is an example. This is shown how it looks like in the memory. So this is array of C of 0. This is the first location, and then it goes all the way to C of 11. It means this array is of size 12 because 0 is also included and there are 11 more. So it is 12, but the index goes from 0 to 11. So if I were to write C out C of 5, it means this value is going to be printed. So this here will result in printing of -89. If I try to exceed the value, if I write C out C of 12, now there are not 12 locations, there are only 11 here. If I write C of 12, this is going to give me an error. This is called a runtime error. It means it won't give me an error at the time of compilation, but it is going to give me an error during when the program is being executed. So at the time of compilation, I am using the correct syntax. The name of the array, open bracket, the index and close bracket. Now it could be 12, it could have been x, it could have been any value. I could have taken this value from the user. So it has no way of knowing what you're trying to index is either going to be legitimate or not. So it's not going to give you an error at the time of compilation, but it's going to give you an error at the time of execution. when you run the program, that is when you will have an error. And basically it's going to access something which is not a part of the array C. So now that we have seen what an array is, let's look at the definition or the syntax, how you write it in C++. So if you want to write an array, the syntax is this. You write the data type, the variable name, and the size. So this here means you are creating an array of size 10 starting from 0, 1 and so on up to 0, 1 up to 9. This is what you have created, and the starting locations, this location here, this is called C. So this is the interpretation of what this means. This is called C, is a starting location, or C of 0, and there are 9 other places, so it's a total of 10. Each block over here is an integer, so each block here is 4 bytes. This is also 4 bytes and so on. So each block is 4 byte because it is of type integer. The name C is the name of the starting location, and it has a total of 10 elements. It means there are 10 spaces reserved, the index of which will be from 0 to 9. This is what this means. This is a float, so if float is type maybe, I don't know if maybe if integer is 2 byte, then this will be 2 and float is 4 byte, or if it is 8 byte, then this high will be of, each block will be of 8 bytes. But the syntax is like this. You are going to write the data type, the name of the variable, and the size of the variable. This is how you define an array. So here you are just declaring an array. You're not initializing an array. Just like we had int x, it's a declaration, and then x is equal to 5 is the definition of that, or it's the initialization of that. So here you are just declaring it, just like you did this. This is what this is doing. Once you declare the array, at some point you have to initialize all these values. What are these 10 elements? So that we can either do directly. For instance, this could have been int x is equal to 5. So I am declaring and defining in the same statement. Here I am declaring differently and defining it or initializing it differently. So the way to initialize is like this. I can write int n5 and then initialize it directly. So what this will do is it will create an array of size 5. So I have 1, 2, 3, 4 and 5. The indices are 0, 1, 2, 3 and 4, and the values will be 1, 2, 3, 4 and 5, these values. So what I am saying here is, this is the initialization. The first element goes to the first location, the second element goes to the second location, and so on. So I can do that, or I could have initialized it using a loop if I wanted to. So I can write int n5. This is a declaration that there's going to be an array whose name is n and whose size is 5. And then I could have written for int I equal to 0, I is less than 5, I plus plus, and then n of I is equal to I plus 1. Why I plus 1? Because at location 0 I want to put 1, and location 1 I want to put 2. So whatever is the index, I want to put a number that is 1 larger. So this what I did over here and this are exactly the same thing. This is declaring and defining or initialization in the same sentence, and this is done in different sentences or different not sentences but different lines of code. So if there are too many initializers, a syntax error is generated. If I write int n of 5 and I initialize everything to, I put it like this, equal to 0, it means all the elements will be set to 0. So if I have 5 elements, each of the 5 elements will be set to 0. If the size is omitted, the size is determined by the number of elements over here. So if you see, I have written n5. I am initializing an array n of size 5. Here I have omitted the size, but I have given the value. So it's going to count how many values, 1, 2, 3, 4, 5. Since there are 5 values, it will automatically put 5 in here for you. The compiler is going to do that. But that only works only and only when you are initializing in the same line as you are declaring. You cannot do like this, int n without giving the size and then use this for loop, whatever I have done over here. For int I equal to 0, I is less than 5, I plus plus, and then n of I equal to I plus 1. This is not possible because here the statement is completed. Once you have a semicolon, it is completed. It means you have declared an array whose size is unknown. So it is not possible to separate the two if you are using this methodology. If you don't want to put the number, you have to initialize in the same line. You cannot do something like this. If you want to do something like this, then use this methodology. So here is an example. You can see that we have an array n of size 10 which is initialized to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is all the indices. Let me just okay. So when you see out element, okay, what is this set w13? And for this set w, you have included this IO manip as well. This is set w, set width 13. It means that you want to format the data. You know, if you see over here, element is here. This 0 was not written over here, and this 32 did not occur over here. There's a gap between, there's a gap before 0 and there's a gap before 32. So this gap from here to here and this gap from here to here, this is what this set w is doing. So it's saying that set the width of whatever you are going to output to 13. So 13 characters की जो जगह है वो इसको दो, उनमें से 2 यहाँ पे यूज हो रहे हैं और एक्स्ट्रा जो है यहाँ पे जो है वो सेट w13 आपने कर दिया है, विड्थ आप बता रहे हैं इसकी, ताकि इस फॉर्मेट में आए नजर. So see out element set w is for the width, and you are you're trying to and the value. So ये आपके पास हेडिंग आ गई यहाँ पे, ये एलिमेंट और ये वैल्यू. उसके बाद आपने क्या किया, लूप लगाया 10 तक, 0 से स्टार्ट किया तो 10 इंक्लूडेड नहीं होगा, लेस देन 10 होगा. सेट विड्थ 7, आई को आपने जो है वो कर दिया, आई जो है वो इंडेक्स है यहाँ पे जो चल रहा है. सो एलिमेंट 0 में क्या आपके पास है और n ऑफ आई. एलिमेंट 0 में आपके पास पहला था, 0 लोकेशन पे 32, फर्स्ट लोकेशन पे 27, सेकंड पे 64, एंड ये सारे आपके पास आउटपुट आ गए हैं यहाँ पे. So this is a simple example in which you are declaring and defining an array in the same line and then simply using a loop to output what you have stored in that array. Let's look at a few more examples. Okay, with arrays there are some things you can do and some things you can't do. So you cannot have and this is generally true for everything. You cannot have a constant int x and then initialize x to something. Once you write the keyword constant to x, it means that x cannot change. So you cannot use this statement, x cannot change. Anything you write when you are defining an array must be a constant. What it means is I cannot do something like this, int n and यहाँ पे मेरे पास int x होता और कुछ भी नहीं है यहाँ पे, और या x इज इक्वल टू 7 में कर दूं यहाँ पे, और साइज ऑफ x यहाँ पे हो और बाद में x इज इक्वल टू 7 कर रहा हूँ. This is not possible. Why? This is very confusing. This is n and this is x. So why this is not possible? Because what I need over here needs to be a constant, and whatever I define here I need to make it a constant, and a constant is something that I cannot change over time. So if I wanted to do something like this, what would have been okay would have been constant int x equal to 7. And this tells me x is a constant whose value is initialized to 7, and then x cannot change. So later I cannot write x is equal to 8. This won't be allowed if I use this. So what I'm trying to say over here is that whatever you are writing in as the initialization or the size of an array needs to be a constant. It cannot be a variable. This is a variable because x can change. So it needs to be a constant. It has to be something that cannot change, because one of the definitions of array was that all the data types are the same and it is static. It means the size is predetermined. You cannot increase or decrease the size. The reason being that if I use x as a variable over here I can have x equal to 7, next line I can have x equal to 8. It means the size is going to be increasing and decreasing. So I cannot do that. It has to be a constant. The next thing I need to look at is how I can pass my array to function. So the way to pass an array to function is rather similar to the way we pass a variable using the call by reference. If you recall, in call by reference we are basically passing the address of the variable, and array also points to the address of a variable. So it specifies the name without the brackets. If I want to pass an array, I need to specify the name of the array but without the brackets. So if my array was defined like this, int the name of the array was my array, the size was 24. So this is the name. What I'm going to do is pass the name separately and pass the size separately. So function call, if there is a function my function, to make that function call it will have to look like this: my function, my array 24. The name of the array is separate, the size is separate. So I don't need to pass this from a syntax point of view, but if I don't pass this, how am I going to make sure in the function that I don't cross the size of this, I don't cross the limit of this? अगर ये array 10 साइज की थी और मैंने 10 यहाँ पे नहीं पास किया, सिर्फ नाम पास कर दिया, टेक्निकली दैट इज फाइन, आई कैन डू दैट. लेकिन अगर मुझे पता नहीं है कि इसका साइज 10 है और फंक्शन के अंदर मैं कोई लूप लगा लेता हूँ जो कि इसका 11th एलिमेंट एक्सेस कर रहा है, तो वो मुझे एरर दिया करेगा. अगर मैं पास करूँगा तो एटलीस्ट मैं अपने कोड में जो फंक्शन में लिखूँगा वहाँ पे रिस्ट्रिक्ट कर सकता हूँ वेरिएबल को कि वो इस साइज से ज़्यादा ना हुआ करे. रिस्ट्रिक्ट फिर भी मुझे ही करना पड़ेगा, ऑटोमेटिकली नहीं होगा ये. So arrays are passed using call by reference. The value of the name of array is the address of the first element. If you recall, we said if we use that housing analogy. So ये मेरे पास जो सड़क थी जो यहाँ पे जा रही थी, और the first house was 160 and then we had all these houses. So ये जो एलिमेंट था जो कि हमारा नेम ऑफ एरे है, दिस इज बीइंग पास्ड. ठीक है, और कितने यहाँ पे इसमें एलिमेंट्स होंगे वो पास हो रहा है यहाँ पे. सो व्हेन आई पास दिस, it means that I know the starting location, and because arrays have to be contiguous or continuous or consecutive, it means that I just need to add the size of the data type and I'll go to the next. अगर 4 बाइट का साइज था तो अगले पहले 4 बाइट में पहला वेरिएबल है, अगले 4 बाइट में दूसरा है, उससे अगले में तीसरा है, उससे अगले में चौथा है. सो फंक्शन में जो है वो पास बाई रेफरेंस हो रहा होता है. वाई? because my array, the name of the array, the variable name of the array variable is always the starting location of the first element. तो ये एलिमेंट मैं पास कर रहा हूँ. अगर int टाइप की है और int अगर 4 बाइट का है तो पहले 4 बाइट में 0 होगा, अगले 4 बाइट में 1 होगा, अगले 4 बाइट में 2 होगा एंड सो ऑन. सो मुझे एक्सेस करने में मसला नहीं होगा वहाँ पे. सो इफ आई वांट टू, और जो फंक्शन आप डिफाइन करेंगे ये तो था आपने मेन में कॉल किया है. सो लेट्स डिफाइन अ फंक्शन. मे बी इट इज void and my function, or here I want to get an array, so I'm going to write int. Using this I'm going to write b, or any variable I can choose of my own. So this is the array that is being passed, and int size s. This is the size of the array. So if I want to access the array over here, I will simply for instance I will write cout b of 1. So this is going to print the second element of the array because it starts from 0, so 1 is the second element. And since this is void, there is no return type I can do here. If I want to make sure that I ask the user which value to print, I can write so instead of here I can write cout which value do you want. I can ask the user and then have maybe int a and then c in a. So user is telling me which of the elements I need to print. Now here I need to be careful that what if the size of the array that was passed to me was 10, but the user says I want to print 20, so user enters 20 and I get 20 in my a. So here I need to look at if a is less than s, only then I can cout b of a, and this is my end of function. So don't confuse this b of a saying ये तो आपने वेरिएबल पास किया है. हमने कहा था कि आप यहाँ पे वेरिएबल डिफाइन करते हुए नहीं पास कर सकते. ये नहीं कहा था कि इंडेक्स करते हुए नहीं कर सकते. आप जब डिफाइन कर होंगे कि जी b एक एरे है, उसका साइज क्या होगा, वहां पे कांस्टेंट आना था. इंडेक्स करते हुए आप वेरिएबल बिल्कुल ला सकते हैं. पहले भी हम लूप में आई यूज करते रहे. तो ये तो मेरा फंक्शन हो गया जहां पे मेरा मेन होगा. सो इंट मेन, यहाँ पे मैं कोई वेरिएबल एरे बना दूंगा इंट array of 10, or this is equal to, अच्छा, this also be noted, the size of the array when I'm indexing or using the value of an array, whether I'm defining or I am using an index. I'm using the square brackets. When I initialize, I have to use the curly bracket, the same bracket you use for opening and closing of blocks. So maybe this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. तो लोकेशन 0 पे 1 आएगा, लोकेशन 1 पे 2 आएगा एंड सो ऑन. ये मैंने एक एरे डिक्लेयर और डिफाइन दोनों कर दिए यहाँ पे. और यहाँ पे मैं इसको जो है वो कॉल करना चाहता हूँ, तो my function, which is the name of the function, जिसको मैंने कॉल करना है। void है, रिटर्न कोई टाइप नहीं है, तो आई एम नॉट एक्सपेक्टिंग एनीथिंग। इसमें मैंने एरे पास करनी है, तो एरे का नाम ARR और एरे का साइज 10, ये मैं कॉल करूंगा यहाँ से। दिस इज हाउ इट्स गोइंग टू लुक एज, एंड दिस इज कॉल्ड बाय रेफरेंस। ये मेरा रिटर्न 0 है। व्हाट दिस मीन्स इज कि मेरे पास एक लोकेशन है यहाँ पे, फिजिकली मेरे पास एक ही लोकेशन होगी जिसमें 0 1 2 3 4 5 6 7 8 9 और 10 ये आ जाएंगे। 0 1 2 3 4 5 6 7 8 9 एंड 10, और वैल्यूज इनमें क्या स्टोर होंगी? 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9 एंड 10। सो ये नहीं होगा, मेरे पास 0 से 9 तक होंगे इंडेक्स, दिस इज नॉट इंक्लूडेड। सो what actually is happening here in the main, this place is called, this location here is called array ARR, इसका ये नाम है array, इसका साइज क्या है? 10 है। जब मैं फंक्शन में कॉल भेजूंगा इसको array को, तो पास बाय रेफरेंस हो रहा है। इट मीन्स दैट इन द फंक्शन देयर इज एन array कॉल्ड b, जो कि एक array है, वो भी इसी लोकेशन को पॉइंट कर रही होगी। तो बेसिकली जो मैंने काम किया है यहाँ पे फंक्शन में, वो द एड्रेस ऑफ द फर्स्ट लोकेशन ऑफ दिस एरे इज पास टू द फंक्शन एंड स्टोर्ड इन द वेरिएबल कॉल्ड b। सो अगर मैं यहाँ पे सी आउट करता हूँ एरे ऑफ 5, तो इस एरे ऑफ 5 की जगह क्या होना चाहिए? सी आउट 6, ये वाली वैल्यू सी आउट हो जाएगी। अगर मैं यहाँ पे कहीं पे जाके करता हूँ सी आउट और बी ऑफ 5, तो ये भी इसी एरे में जाके इसी 5 लोकेशन पे इसी 6 को सी आउट करेगा। अगर मैं बी में चेंज करता हूँ तो एरे में भी चेंज हो जाएगा। दिस इज वेयर दिस इज कॉलिंग बाय रेफरेंस। इधर मैं चेंज करता हूँ तो जो फंक्शन में था यहाँ चेंज हो जाएगा, इधर मैं चेंज करता हूँ जो मेन में था यहाँ पे चेंज हो जाएगा। क्यों? क्योंकि एरे बेसिकली एक ही है, उसके सिर्फ 2 नाम है। मेन में जब मैं कॉल करता हूँ तो उसका नाम एरे है, फंक्शन में जो कॉल करता हूँ तो उसका नाम बी है। एक्चुअली ये वही लोकेशन है। इसमें चेंज करूंगा तभी वही लोकेशन चेंज होगी, इसमें ये करूंगा तभी वही चेंज होगी। सो दिस इज व्हाई वी से दैट पासिंग एन एरे इज पासिंग बाय रेफरेंस। So here is an example considering whatever we have learned so far and putting it all together. So here I have using stdcout या इसकी जगह मैं using namespace xd भी लिख सकता था, and iomanip is for the set w. So there are two functions that I'm defining here. The first one is modify array, and it is being passed the entire array and the size of the array. And then the second function is modify element. It means I'm not passing the array, I am passing a single element of the array, not the entire array. उसमें से एक वैल्यू सिर्फ भी पास कर रहा हूँ. So ये जो है वो modify array करेगा, ये modify element करेगा. दो फंक्शन मैंने बनाए. So here I have constant int array size equal to 5. Int, I have two variables. I is a simple variable of type int. A is an array variable also of type int, which is of size 5, and the initialization is 0, 1, 2, 3 and 4. If I write C out, the effect of passing entire array called by reference is, and then I am using this for loop to output A of I. A is the variable in main. So ये वाला loop जो है, this is trying to see out whatever is in the main, and L, and then I am calling modify array. So ये जो function call हुआ है, which we will see what this code is actually doing, we'll see in the next slide. You are trying to output whatever was before, call the function and then output again. तो पूरी array आप पहले output करेंगे. पहले क्या थी? फंक्शन कॉल करेंगे, फिर देखेंगे फंक्शन के बाद क्या हो गई है. So before the function, once you run this loop, it's basically printing the values. So क्या print होगा आपके पास 0 1 2 3 4 ये print हो जाएगा. This is what it's doing, right? This is after the again doing the cout, but after calling the function modify array. Now this is after calling the function, after calling the function. Let's skip the rest of this code and see कि modify array करता क्या. We'll come back to here. यहाँ पे हम एक stop लगाते हैं और we'll come back to that. Let's see what modify array does. What modify array is doing, it is taking that array in the variable b, and for int j equal to 0, j is less than size of array j plus plus, b of j equal to b of j multiplied by 2. So you are basically multiplying every element by 2. This is what modify array is doing. So ये जो है वो loop main में आपने पहले आउटपुट किया था, एरे क्या है, फंक्शन कॉल किया था और दोबारा आउटपुट कर दिया. सो यहाँ पे आपने पहले लिखा था ये एरे क्या है, तो उसने जो ओरिजिनल वैल्यूज है ये दिखा दी थी 0 1 2 3 4. फिर आपने कॉल किया मॉडिफाई एरे. मॉडिफाई एरे अभी हमने देखा क्या कर रहा है, हर एलिमेंट को 2 से मल्टीप्लाई कर देता है, और उसके बाद अब यहाँ पे दोबारा सी आउट कर रहे हैं. इसका मतलब ये है कि आपके पास जो वैल्यूज हैं दे शुड हैव बीन मल्टीप्लाइड बाई 2 बिकॉज इट वाज द सेम एरे वेदर यू कॉल इट ए इन द मेन और b इन द फंक्शन. एक ही चीज को रेफरेंस कर रहे हैं. सो बेसिकली आपके मॉडिफाई एरे की वजह से ये वैल्यूज मल्टीप्लाइड बाई 2 हो चुकी होंगी 0 2 4 6 8. So because of this loop this should be output, and because of the next loop the second one this should be output. So इस loop की वजह से अगला वाला आउटपुट हो जाएगा. नाउ यहाँ पे हमने रोका था, हमने कहा था अभी वापस आके देखते हैं कि बाकी का कोड क्या कर रहा है. तो यहाँ से हम आगे चलते हैं. You have output. So the next thing is कि you are trying to see what is the value at location number 3. So let's see what is the value at location number 3. This is location number 0 1 2 and 3, और ये value जो है ये अब 6 हो चुकी है. So if you output what is the value at location 6, it's location 3, it should give you the value 6. So because of this it should output the value 6, and then you are writing modify element a of 3. Now what is modify element doing? Here you are passing a variable, you are not passing it, you are passing it by value, not by reference. It means a of 3 and e are two separate locations. If you change e, you are not changing a of 3. This is passing by value. So once you pass by value, the value of whatever was in a of 3, which is 6, is copied to a new variable called e. So e is a new variable which has the value 6. If you change e, you're not changing a of 3. So even if you do e equal to e into 2, so this in the function will see out 12, but if you see out again what is a of 3, this is again going to give you 6. So this here you're calling the function will give you 12, but before the function it was 6, after the function it was 6. Whereas in the case of the whole array, before the function it was 0 1 2 3 4, after the function, after calling this modify array function, it is 0 2 4 6 8. Why? Because it was called by reference and the entire array was the location of the entire array was passed, and whatever you modified in the functions got also modified in the main. So we can see the output over here. This is a 0 1 2 3 4. We just looked at it, and after modification it is 0 2 4 6 8, whereas in the case of a single element it was 6 before. In the function it got modified to 12, but that did not change whatever was in the main, and back in the main if you try to output a of 3, it is still 6. So passing the entire array is passing by reference, passing an element of an array is passing by value. So with that, we'll come to an end to this lecture, and in the next class we'll have an interactive session, and then we'll move on to further discussion of arrays. This is a one-dimensional array. So far what we have done, there is only one index. It's a one-dimensional array. It's a row vector or a column vector. Next we will see if we have two-dimensional, for instance a matrix. So if you have any questions, you can ask me on MS Team, or you can ask me during the interactive session. So I hope you enjoyed this video, and I hope you will watch it before coming to the class.